Hey everybody, today we have 10-2 reteaching. The objective for this lesson is to estimate the sums and differences of mixed numbers. It's going to be very similar to the previous lesson about estimating sums and differences of fractions. So here we are asked to estimate the difference, and our problem is 6 1/3 minus 3 5/7. So what we need to do is figure out if 6 1/3 is closer to 6 or closer to 7. So similar to rounding our fractions, we're going to draw a number line. This is a pretty short one. And 6 1/3 is going to be between the numbers 6 and 7. So if we divide this line into thirds and then go ahead and plot where 6 1/3 is, you can see that the distance between 6 1/3 and 6 is shorter than the distance between 6 1/3 and 7. So in this case, our 6 1/3 is going to round down to 6. Now we need to figure out if our 3 5/7 is going to round up to 4 or down to 3. So let's draw a number line here again. 1, 2, 3, 4, 5, 6, 7. Okay, so if I plot the numbers 6 and 5/7, I just count over 1, 2, 3, 4, 5/7 and plot my point right there. And let's take a look at the distance between that mixed number and our two whole numbers. So it looks like that this 3 5/7 is going to be much closer to the 4. So when we're estimating, we're going to round that 3 5/7 up to 4. So an estimated difference for this problem is going to get us 2. You could also take a look at the actual fractional parts, and you see that 5/7 is greater or is closer to 1 whole, which would be the 7/7, than it is to say no fraction at all, which would be 0/7, which would just give us 3. So you can see that it's much closer to the 7/7, but the number line is another way to look at it, especially if it's a fraction that's not that obvious with. So for this problem, we're going to do the same thing as we did for the last one, only we're going to add these two numbers instead of subtract them. So for the 4 1/8, I'm going to draw my number line again, and this number falls between the whole numbers of 4 and 5. So then I'm going to split my number line up into eighths, pretend like these are equal, and I'm going to plot my 4 1/8. It's going to be on that very first bar. So it's pretty obvious here that this mixed number is much closer to 4 than it is to 5. So that's just going to go ahead and round down to 4. Now let's do the same thing with our 7 2/3. This number falls between 7 and 8. I'm going to split my number line into thirds, plot my point. So 7 2/3 falls right there on that second tick mark. And then look at the distance between 7 2/3 and 8, and look at the distance between 7 2/3 and 7. Notice that it's much closer to 8 than it is to 7, so this one is going to round up to 8. So our estimated sum for this problem is going to be 4 plus 8, which is going to get us 12. So that's how we're finding the estimates of mixed numbers. It's very similar to finding the estimates of fractions, only instead of looking at 0 and 1, we're looking at the two numbers that are above and below, the two whole numbers that are above and below our mixed number.